All right, welcome to pre-calculus, prep for pre-calculus. This is coming from the getting ready section for pre-calculus of Khan Academy. They've pulled together topics that you've seen before, but you need to study. As you can see, I need to study too. So that's why we're doing this. So what is the square root of a negative? We know we can't take the square root of a negative, so we use the letter I. So the square root of negative 25 would be 5i. The square root of negative 23 would be I times the square root of positive 23. In fact, let me write this like this. I times the square root of 24. Let's see. Is that right? No, it's not right. So then we click get help and we find out, oh yeah, we have to simplify the square root. See, that's why we have to do this. So they said, oh, simplify. So the square root of 24, how do we simplify that again? What we do is we think of factors that multiply to 24, and we want one of them to be a perfect square. So is it true that 4 and 6 multiply to 24? But the square root of 4 times the square root of 6, that would equal the square root of 24, which is what we want. And furthermore, the square root of 4 is 2. So it's 2 root 6. And so we can see 2 root 6. All right, let me try one. I'm going to get this right, you see. I am not going to have... I got it. The square root of 64 is 8. So this is 8i. Ta-da! I'm ready for pre-calculus. All right. Okay, so the next thing is complex unit is the powers of I. We always do the powers of I after we introduce I. Why is that? It's because there's only 4 choices, right? So when you think about your exponents of I, they're either going to be even numbers. So we can say exponents of I. They're either even or they're odd. And then you can divide by 2, and you can divide an even number by 2, and you can end up with the even number, or you can end up with the odd number. And you can also divide an odd number by 2 and end up with the even, 0.5, or an odd 0.5. Don't even worry about the 0.5s. So these 4 categories give us our 4 solutions for I. So if it's even divided by 2, it's still even. The answer is 1. This one would be -1, even divided by 2, odd, -1. Odd divided by 2, even, I. And odd divided by 2, odd, -I. Notice our odds are the negatives, and our evens are the positives. If it's initially even, it's going to be some sort of a 1. If it's initially odd, it's going to be some sort of an I. And this little organization is how I remember it. So 21, I to the 21st. Well, immediately I know it's in the odd category. And if you divide 21 by 2, you get 10.5, and 10 is an even number. So that brings us to I. So let's pick I. All right. So that'll get you started with the powers of I. And now where did I just go? We want to go to parts of a complex number. So what are the parts of a complex number? What is a complex number? So we have real numbers. And we have imaginary numbers. And if they are added together, that is called a complex number. So what is a real number? You know, anything without the letter I, anything at all that doesn't have the letter I. So we just call it like A. You know, A can represent anything that doesn't have an I. And then an imaginary number must have an I. So how about BI? And then A plus BI. Don't think of it as A and BI like A, you know, like 2 plus 3x. Think of it as one number. It's a number with a plus sign in the middle. That's complex. So what is the real part and the imaginary part? Well, we can see the imaginary part. Now see, this is where we get to gear up. I would have to say that the imaginary part is negative 12.7 I, which is right here. Imaginary part, negative 12.7 I, and the real part, negative 24. Now, it's true that it could be without the I, but we're about to find out. It's without the I. It's not without the I. It is without the I. It's that one. So now we just learned something. The imaginary part is just the coefficient, the thing next to the I. So let's use that. Let's use that knowledge. And so we know that this is 23.3. And the imaginary part is only the 44. Ta-da. But we better look at what they have to say about it. As you can see, I forgot. In this case, it's of the form BI plus A. I said that. Therefore, the real part is, okay, in summary, the real part and the imaginary part. All right, so there you go. All right, classify complex numbers. What type of a number is 33I? It's imaginary because it doesn't include a real part. It's not complex. It's not a real number. Oh, sorry. It is complex. I know. Before you lose faith in me, I'm going to tell you why it's complex. The real part is 0. Although I wasn't wrong to say it's imaginary, it's just also a real complex part. All right, let's try again. So now what about this? Would that mean that this is complex too? Because it could be 0I. Let's do negative 3.709 plus 0I. That's a complex number. And so we're going to say real and complex. We're learning, we're getting right. And this is just complex. It's just plain old complex. Yeah, I just got, all right, complex and imaginary. All right, look at that. Next, we can plot complex numbers on a coordinate plane. So instead of an X, Y axis, our X-axis is the real number axis, and the Y is the imaginary axis. So where would 8I be? And now see, we're putting all these things together. This is why it's a complex number. It's 0 plus 8I. That's the real part, the imaginary part. And you can now see why we don't include the I. And then we would have to write I's all along the imaginary axis, and that would be redundant. We've already labeled it the imaginary axis. And so up 8 on the imaginary axis is 8I, you see? And that's where this point is. Negative 7 is a real number. And so that's an x-intercept there. So, finally a complex number. So we're going to go left 9 and then down 7. And it's right here. How fun. add and subtract complex numbers. This should be no problem for our Algebra 2 graduates because it's just like adding binomials, right? And so we're going to add our real parts. Negative 55 plus 13 that's the 42. It's positive 42. And then 94i minus 12i is going to be the 82i. So are we looking at 42 plus 82i? Let's see. 42 plus 82i. Now, what did I do wrong there? Let's click the Get Help button. Negative 42. Can you believe I forgot the negative? How many people saw that I forgot the negative and knew I was going to get it wrong? But it's summer. We're doing this over the summer, so it's no pressure. This is not going on the transcript. We can learn so that when it does go on the transcript, we are ready. Now, don't forget to distribute your negative signs here. So I always like to rewrite this one. I'm going to write negative 8 minus 6 minus 30i. And then combine our like terms, negative 14 minus 30i. All right, negative 14 minus 30i. Yay. Moving on. I'm multiplying the complex numbers basic. So all we need to know here is that I squared equals negative 1. Because I is defined to be the square root of negative 1. If you square the square root, then you undo it. And then you get what is left underneath. And that's amazing. Okay, so we're gonna distribute, and we're gonna write negative 36i plus negative times a negative 12i squared, which is negative 36i minus 12, because 12 times I squared is 12 times negative 1, which is negative 12. So that's why we have the negative 12. And we combine these. I wouldn't. The I is there. So we're just going to write it as a complex number. All right. See, just had to warm up. Now the complex numbers, non-basic. We are going to use the area model. Of course, you can FOIL. You can do whatever you want. Just get the answer. Show your work. So I'm going to put the first one on top, like so. I'm going to put the second one along the left side. And negative 3i, and I'm going to multiply in like a Punnett square. Negative 5 times negative 4 is positive 20. Negative 5 times negative 4 is positive 20. This time there's an I there. Negative 4, negative 3 is 12 with an I there. Negative 3 and negative 4 is 12i squared. Circle this guy because we know I squared is negative 1, so that's negative 12. And then 20 minus 12 is 8. And 20i plus 12i is 32. And that is our final answer, complex number. 8 plus 32i. Oh yeah. And the last one, quadratic equation. In Algebra 1, they only had real answers. In Algebra 2 and Precalculus, we get imaginary answers too. 1 second. All right, so find the solutions of the quadratic equation 7x squared minus 2x plus 3. So we are going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Great song. You can look it up. Mr. Field, quadratic formula. Okay, so A on YouTube. A equals 7. B equals -2. And C equals 3. We can label those because it's already equal to 0. If it wasn't equal to 0, we would have had to get everything on one side. So now let's substitute it. Negative, positive. The square b squared is going to be -2 squared. 4ac, something like that, all over 2a. 2 times 7. All right, so I always like to do the inside, kind of do it all together here. It's complex, so we don't want to try to put the square root part in our calculator. Plus, we're pre-calc students who does that. So this is 4 minus 28 times 3 was 28 times 3. 24, 6, 8, 84. Uh-oh. The square root of -80. So we have 2 plus or minus the square root of -80 over 14. And I don't even see the square root of -80. So we're going to have to simplify that. So what is 80? 80 is 4 and 20. So the square root of 80 is the square root of 4, square root of 20. But then 20 is the square root of 4 and square root of 5. And both of these are 2. So 2 times 2 times root 5. In other words, 4 times root 5 plus minus 2 over 14. But the 2, the 14, and the 4 all have a common factor of 2. So we can divide all of them by 2. Giving us our final answer of 1 plus or minus 2 root 5 over 7. Do I see that? I see. All right. Okay, we could write it like this: 1/7 plus minus 2 root 5 over 7. Do I see that? 1/7 plus minus 2 root 5 over 7. See. Okay, let's click it. Oh my gosh. Why? Why? Okay. I might have made a mistake with the signs. You think? You think I did? Oh, the I. I forgot about the I. All right. Don't forget about the I. You're going to do great. You're going to do even better than me. And then we'll talk about it. Bye, everybody.